Okay, let's go ahead and finish 3.1 with functions. Do some operations with them. So function notation and operations. You did see this in algebra last year, third quarter. So you guys were still all there. So here, when you see this notation, f plus g of x, that just means you're going to add the f function plus the g function. If there's a subtraction, that means you're going to subtract the two functions, being very careful to distribute your negative sign. And this is multiplying your two functions. You're going to go ahead and multiply them. And this is going to be division. You're going to go ahead and divide your two functions. So it seems pretty straightforward. So we're going to find the operations, and then we're going to calculate the domain, which is the intersection of the two. So we'll go over what that means. So the first one is adding f of x plus g of x. So I'm going to take the f of x function from the top, which is 2x plus 1. And then I'm going to add to it the g of x function, which is 5 over x minus 1 minus 2. And I'm going to combine my like terms and solve. So I've got a plus 1 and a minus 2. That's the easiest to go ahead and combine here. So that's going to give me 2x plus 5 over x minus 1, and then plus 1 and the negative 2 combined to a minus 1. There's lots of different ways you can write that. If you wanted to write that as 2x minus 1 plus 5 over x minus 1, that would be fine too. But you have three terms as your answer. And that's as simplified as we're going to make it. The domain is going to be, when you look at the answer, using all the rules from before when we talked about square roots and fractional answers. So this one has a fraction in it. So we need to zoom in on this part here. X minus 1 cannot equal 0, right? Because you can't have 0 in the denominator. So we learned from our last set of notes, we're going to set the denominator not equal to 0 and solve. So that means x cannot equal 1, which means the domain is everything but 1. So we're going to go ahead and write these in interval notation. So if it's everything but 1, that means from negative infinity up until 1, union 1 until infinity. That is your domain. Okay, if we take a look at part B, we're subtracting. So this means f of x minus h of x. So you're going to take your f of x function, which is 2x plus 1, and we're subtracting all of h of x, but h of x happens to be just one term, which is square root of x. You look to combine. There's nothing you can combine here. It stays like this. This is done. No like terms. Now, using our rules, you want to watch out for fractions with an x and square roots. Look at, we have a square root. So we know when you have a square root, you're going to set the inside greater than or equal to 0. So that means it's everything 0 or above. So the domain here is going to be from 0 until infinity. Okay, the next one we're going to do is a multiplying one. So we're going to do f of x times j of x. So f of x is 2x plus 1. J of x is negative 4x minus 8. So this really just turns into an algebra 1 problem where you would have to FOIL. So 2x times negative 4x is negative 8x squared. 2x times negative 8 is negative 16x. 1 times negative 4x is negative 4x, and 1 times negative 8 is negative 8. So from there, you're going to combine your like terms. And I have a negative 16x minus 4x, that's negative 20x. And that is all I can combine. So I've simplified it. Now I need to look at the domain. The domain does not have any fractions with the x, and it does not have any roots. Square roots are radicals. So the domain for this one is going to be negative infinity until infinity. It's all real numbers. All right, the other one we talked about is division. So now we're going to practice a division one. So we're going to do f of x divided by h of x. So f of x in this case is 2x plus 1. Actually, I'm going to move it over because I need a little bit of room. So we have 2x plus 1, and we're dividing it by the square root of x. And we have to simplify. The rules that you guys have been learning since Algebra 1 always apply here. So you can't have a square root in the denominator. So we have to go ahead and multiply by square root x over square root x. That's to rationalize it. And that's going to end up getting, because we have to distribute that square root x to both terms in the numerator, we're going to end up with 2x times square root x plus 1 times square root x is just square root x. Over, if we take a look at the denominator, square root x times square root x is going to just give us a x. So we can go ahead and simplify a little bit more. I'm going to break this up into two fractions. This is one fraction, and this is the other fraction. They're both over x, so I'm going to rewrite that as 2x square root x over x plus square root x over x, because I noticed that some things can cancel. Now I can go ahead and take out an x in this section, an x over an x. I couldn't do that before because the x's were under the square root for the second term, and there wasn't an x there. There would have had to be an x here in order for you to cancel it, but there's not. So I'm simplifying again. And that gets me to 2 square root x is the only thing left on that first term. And then the other term I can't do anything with, plus square root x over x. So there's a lot of different things going on, because now we have to take a look at the domains. And I said to watch out for square roots and fractional fractions where there's x's. So there's this square root, and you're going to set the inside x greater than or equal to 0. We have this one up here, same thing. I'm going to set the inside, which is x, greater than or equal to 0. So those two things happen to be exactly the same. And then we also have the x in the denominator, and you cannot have a denominator equal to 0. So x can't equal 0. So if you take that into account, the fact that x cannot equal 0 and x is greater than or equal to 0, then their intersection of those two would just be x is greater than 0. So the domain is x is greater than 0. And to write that in set notation, we would say from 0 until infinity. You might have to do some computing as well with actual numbers, but it's really no different. So for the computing, you would be doing f of 10 minus g of 10. So step 1 would be to go ahead and find f of 10. So I'd go to my f function and I'd plug in 10. So 2 times 10 plus 1. That's my first function. Then I'm going to add to it the g of function, I'm not adding, subtracting. I'm going to subtract the g function, and the g function is 5 over 10 minus 1 minus 2. And if this is what you would write, this would actually be wrong. So you have this function minus this function, but what you don't have is the parentheses here, because you want to subtract all of g of 10, not just the first term. So when you write this down, you need to have parentheses. So when I start to solve here, 2 times 10 is 20. 20 plus 1 is 21. Minus, here I have 5 over 10 minus 1. So I'm going to have 10 minus 1 is 9. And again, you can use a calculator to go from here, or if you wanted to go ahead and flip the signs yourself, that would be 5/9 plus 2, because again, you have to go ahead and distribute that negative sign, so it ends up being a plus 2. So 21 minus 5/9 plus 2 is going to get you to a 202 over 9. Again, I recommend that you use a calculator to do that. You are allowed to use a calculator on all parts. All right, the next one is a multiplying one. This is going to go ahead and say f of 0 times g of 0. I'm going to go ahead and stop and have you try this problem. All right, welcome back. Let's see if you got the right answer. The right answer is -7 if you did it. So for the f function, when you plug it in, it's 2 times 0 plus 1. The g function, when you plug it in, it's 5 over 0 minus 1 minus 2. So the f function, when I type that in, 2 times 0 plus 1 is 1. The g function, 5 over -1 is -5, minus 2 is -7. 1 times -7 is -7. Okay, again, you have done all of those. The only different thing that you had not done before is talked about the domains in parts A through D. Other than that, everything else is the same from Algebra 2. Now, this next box is actually very important. It's a question they like to put on the final every year. It's called the difference quotient, and they will say to use the difference quotient. So you will know to use it because they will say to use it. And it's a formula to find the slope of a secant line through 2 points on the graph of f. You can use it in calculus, but we'll be using it as an application of operation. So what we're going to do is the formula is f of x plus h minus f of x over h. And I'm going to go ahead and do 2 examples with you. So the very first thing you're going to do, if we do this formula on parts, is find f of x plus h. That's the first thing. So if we look at part A, the first thing I'm going to do is find f of x plus h, which means I'm going to go ahead and replace x with x plus h. That's the very first thing I'm going to go ahead and do. So there's x plus h. Again, I replaced it for x. That's the first thing I'm going to do. And that's going to get me -3x minus 3h plus 7. The second thing I'm going to go ahead and do is this part here, f of x. Well, guess what? If you replace x with x, it doesn't change. That simply is -3x plus 7. So again, you're replacing the x with x, so nothing changes. And what they want you to do is subtract those two. So you're going to take number 1 and you're going to subtract number 2. So what does that look like? We're going to take number 1, which is -3x minus 3h plus 7, and we're going to subtract, and I'm going to use parentheses here, -3x plus 7. And actually, I'm going to rewrite it down here because I'm going way too far into the other problem. So when we put it all together, we get -3x minus 3h plus 7 minus all of -3x plus 7. Let me erase it over here. And then everything is being divided by h. Where did I get that h from? I didn't make it up. It's part of the equation here. It's divided by h, and we have the minus and the minus. So I just copied those things down. So I'm just doing this part by part. Now I'm going to simplify it. So if I'm going to go ahead and simplify it, I'm going to bring my work up here because I'm running out of room. I'm going to have to distribute the negative sign. So -3x minus 3h plus 7 minus, so I have to distribute that negative sign. Negative times -3x is a plus 3x. Negative times positive 7 is a minus 7. And once again, all things are being divided by h. And then I'm going to simplify again. Notice I have some like terms here. I can go ahead and combine, let's see, -3x plus 3x. Whoa, that goes away. That's 0. And then I combine a positive 7 minus a 7. Well, that's 0 as well. So the only thing I'm left with is -3h over h. And then you might be like, wait, now I can simplify even more. Negative 3h over h, the h's cancel. So all I'm actually left with is negative 3. So that is my answer. It simplifies very, very nicely there. So let's try that again. So part 1 is you want to plug in x plus h. I'm going to kind of do it all in one step now. But the first thing I'm going to go ahead and do is plug in x plus h in place of x. And remember, when you're replacing it for x, you have to replace it for both parts. So wherever you see an x that I just highlighted, I'm going to put in x plus h. So I'm going to start by writing, and this one takes some room too. So you got to write small. X plus h squared plus 3 times x plus h plus 1. That's step 1, plug in x plus h, right? Step 2, which I do in pink, I'm going to subtract, because it says subtract, minus. Step 2 is to plug in x. Well, if you're plugging in x for x, it doesn't change. I've got to use parentheses. X squared plus 3x plus 1. And then everything is being divided by h. So I did it all in one step, my plugin. So in the last example, I wrote it down as 2 separate steps right here. I just did it all in one step this time. Now it's just simplifying once you plug it in. So for the green part, you're going to go ahead and x plus h squared, you have to go ahead and FOIL that out, x plus h times x plus h. And that should get you x squared plus xh plus xh plus h squared. So the middle two terms come together. So that's going to get me x squared plus 2xh plus h squared. Now I have to distribute the 3 here. That's going to give me a plus 3x plus 3h. And then I've got the plus 1. Now I have to distribute this negative sign. I have a negative x squared minus 3x minus 1. So this is really just a really long line of algebra, and everything is divided by h. So again, now I'm going to combine like terms. Notice though, a lot of things should drop out. X squared minus x squared is 0. I also have a positive 3x and I have a minus 3x. That is 0. I also have a plus 1 and then minus 1. That drops out. So those are gone as well. So the only thing I have left on the top is 2xh plus h squared plus 3h all over h. Notice every term has an h in it, so there is one more step to do. I can actually go ahead and cancel out an h because this has an h, this has 2 h's, and this has an h, so I can cancel them. And I'm left with 2x plus h plus 3 as my final answer. So again, the steps to do that is you plug in the x plus h, and then you subtract when you plug in x all over h and simplify. We'll practice more of that in class because again, they like to put that on the final every year. All right, the next two examples gives us an equation, except this equation, this function has an a in it, and they want us to find out what is the value of a. So you have to use this information, the f of -1 equals -6, and plug that in. So we're going to take -1, which is in place of the x. We're going to plug -1 in wherever there's an x. And we're going to replace, this is the output for this entire thing. So when you go ahead and you write this, we're going to have -6 equals 7 times -1 cubed plus a times -1 squared plus 6 times -1 minus 4. Again, the -6 was there, and I plugged in a -1 wherever there was an x. And now you're just using your normal algebra to simplify. -1 cubed is a negative number, so I'm going to get -7. Negative 1 squared is a positive number, so that's just 1a. 6 times negative 1 is minus 6, minus 4. Negative 7 minus 6 minus 4 gets me to negative 17. I'm going to add 17 to both sides, and I'm going to get a is 11. Okay, so example 4 is going to be similar to that. There's just an extra step in the beginning that I'm going to help you with. Again, you're going to start by replacing. The 9 is in the place of the b. So where you see the b, you're going to put a 9. And the 3 is the output. That's this entire piece is going to be 3 here. So when we replace it, we're going to get 3 equals 2 times 9 minus 6, all divided by 9 minus a. Again, that was the 3. And this is where I plugged in for the b. Okay, so we want to simplify this. So I can simplify the top pretty quickly. 2 times 9 is 18, minus 6 is 12. And now I want to solve. If we want to get to the a, but the a is in the denominator, the easiest way to probably solve here would be to multiply by 9 minus a to both sides, because when you do that, it drops out on the right side and the a is no longer in the denominator. So then you just have to distribute a 3. 9 times 3 is 27. A times 3 is going to give us minus 3a equals 12. I'm going to subtract 27 to both sides. That gets me negative 15. I'm going to divide by negative 3, and a is a positive 5. Okay, so that's it for the 3.1 section. I will see you in class.